Greetings and welcome to this video, everybody. I actually got some feedback regarding my Java coding challenge video, which I did some time ago. And today I wanted to talk about this feedback and share this feedback with you and also kind of reply to this feedback a little bit. Also, a different friend of mine mentioned that he couldn't read my t-shirt entirely, so here you go. This is the t-shirt I'm wearing today. So the feedback I got from my friend was that by having an array which is either null or is empty, we actually have invalid values here. So last time I mentioned that I'll just return -1 and 0 in those places here. But this is actually not really a very good choice, because here you can't differentiate between if actually I get an array where 0 actually is the biggest number or if the array is empty. So he made the point that if I have invalid values, I should throw some kind of exception. And this is what we're going to do next. So the last time I just wanted to show you how you can write tests for this and just kind of have some tests in place and some functionality in place for invalid values. But with this feedback I got, it actually makes a lot of more sense and is way cleaner if I actually throw exceptions here. So let's do that. So if my array is null here, I'm going to throw an illegal argument exception, because array is null. The array is null, so I can just throw an illegal argument exception here. And if I'm running the test now, it will actually fail, because now I don't get -1 as an argument here. So as you can see, I get an exception here, which is not what is expected in this case. And within JUnit, we can expect certain exceptions to be thrown. And we can do this by adding this expected illegal argument exception to this annotation here, class. And if I rerun the test now it works. We can do the same with the empty array here. I'll just copy this for now, because this is also an illegal argument exception, but in this case we can throw the exception the array is empty, and we can also use this expected here. So this assert equals now doesn't make any sense anymore, so I'll just erase this. Find maximum recursive and rerun the test. And there you go. Now we have some exceptions here. One additional problem which we are facing now is that we now can't see anymore if the array was empty or null, because both times an illegal argument exception is thrown. Sure, we could just pass the message, but I don't think that this is very elegant. So one way how we can deal with this would be to just create our own exceptions. So I'll create a class here, which I'll call empty array exception. And this class will extend illegal argument exception. And since I already know what the message should be, I'll add a constructor, empty array exception, a default constructor which calls the superconstructor and already enters the exception message, which would be the array is empty. And now, instead of throwing a simple illegal argument exception, we'll throw this exception. And we can also expect this exception to be thrown. So let's run the test again. And as you can see, this works. And we could now just write an additional exception for the array being null. This works in an analogous fashion. Recently, I have been using error codes in combination with exceptions. Both have the benefit that you can actually pass them via an API or something likewise, and they are much easier to interpret and parse by a front end, as an example, because in the front end you can just translate this error code into different error messages for different languages and so on and so on. So it's pretty easy to work with from a front end side. Also, other applications which will be using your API as a third-party service can pass those error codes and then can themselves deal with this exception much better. And I'll just provide an example here. So I'm gonna call this general array exception for now. You can also call it a business exception or my platform exception or anything you want. And this extends exception. And here we have an error code for which we will have an constructor parameter. Yes, also it would be good to have this final because we don't want to change it. And also add a getter for this field. And furthermore, we want to have a message here still. As an exception message. And also make this error code final. And if we want to use this now, I just use it for the case where our array is null for the moment. We can now throw a general array exception. And the error code we want to use here, let's just make this the error 13. Yeah, it's not handled. So we need to throw throws, add this here, because it's not a runtime exception. And now we can rerun the test. Or rather more, we'll just add the exception here for now. Now we can rerun the tests. And it fails, pretty much as expected. And now, instead of just expecting this exception for this case, I want to do it a little differently. I want to make sure that the exception is being thrown and also that the error code being thrown is the error code 13. So I expect the error code 13 and I'll create a boolean here. Exception was thrown, which will be false. And in the end, I want to assert this that the exception was thrown. So now I'll just surround this function with a try catch. So first of all, if the exception is being thrown, I'll flip the boolean to true. And I also want to assert that the expected code matches the error code provided. I can also add a message here. Error code did not match. Run the test. And it doesn't work because we are still expecting the illegal argument exception. And now everything's fine. If I change this here to maybe 14, the test should fail. It does. Error code did not match as a message. And there you go. So if you are dealing with unexpected values, it's a good idea in general to throw exceptions in some fashion and deal with those illegal arguments somewhere on a higher level. And especially when you are using a web application, you're providing an API, it makes sense, or at least currently it's pretty easy for me to work with those exceptions, error codes, because it's pretty easy for a front-end developer to use. The front-end developer can just check which error code is being thrown and then either display the error translated in a specific language to the user or deal with this error code somehow differently. This is not so easy when you are just throwing the exception class name or something like that, or when you are just throwing an already translated message where some parsing is needed and so on. So currently I'm in favor of this approach. Maybe you know of a better one. If so, feel free to leave it in the comments. And with that said, I hope that you enjoyed this update to the Java Coding Challenge video. Thank you to Daniel for the feedback and keep on coding.